Imagine all the matter and energy in the universe. Now imagine it packed into a space smaller than a tiny seed. This is how our universe began. This seed held the potential for everything we see around us, the stars, the planets, and even you and me. Scientists call this beginning the Big Bang. It happened around 13.8 billion years ago. It wasn't an explosion in the usual sense, but rather a rapid expansion. Imagine a balloon being inflated at an incredible speed. The universe was incredibly hot and dense at the beginning. As it expanded, it cooled down. This cooling allowed matter to form. The universe is still expanding today. It is a testament to the immense power of the Big Bang. In the first fraction of a second after the Big Bang, the universe was an incredibly chaotic place. Temperatures were unimaginably high, and energy crackled everywhere. As the universe expanded, it cooled. This cooling allowed energy to transform into particles. These weren't the atoms we know today, but even smaller particles like quarks and leptons. These particles collided and interacted at unimaginable speeds. Over time, they began to combine, forming the building blocks of atoms: protons, neutrons, and electrons. About 380,000 years after the Big Bang, the universe cooled enough for atoms to form. Protons, neutrons, and electrons combined to create the first atoms, mostly hydrogen and helium. With the formation of atoms, the universe became transparent. Light, which had been trapped by the chaotic particles, was now free to travel. This first light, known as the cosmic microwave background radiation, still exists today. It provides a glimpse into the early universe. The universe was now dark, filled with clouds of hydrogen and helium gas. Gravity began to pull these clouds together, setting the stage for the formation of the first stars and galaxies. Gravity pulled the clouds of hydrogen and helium gas together. These clouds became denser and hotter over millions of years. Eventually, the pressure and temperature at the center of these clouds became so intense that nuclear fusion began. Nuclear fusion is the process of combining lighter atoms into heavier ones, releasing a tremendous amount of energy. This energy ignited the first stars, illuminating the universe once again. Stars didn't form in isolation but in clusters. Over time, gravity pulled these clusters together, forming vast collections of stars, gas, dust, and planets, galaxies. Our own galaxy, the Milky Way, is just one of billions of galaxies in the observable universe. Section 5. The birth of our sun, a star among billions. Around 4.6 billion years ago, in a spiral arm of the Milky Way galaxy, a giant cloud of gas and dust, known as a molecular cloud, began to collapse under its own gravity. As the cloud collapsed, it started to spin faster and faster. The center of the cloud became incredibly hot and dense, eventually igniting nuclear fusion and giving birth to our sun. The sun, a relatively small and ordinary star, became the center of our solar system. Section 6. Cosmic leftovers, the formation of planets. Not all of the material in the molecular cloud was pulled into the sun. Some of it remained in a swirling disk of gas and dust surrounding our newborn star. Within this disk, particles began to clump together due to electrostatic forces. These clumps, over time, grew larger, forming planetesimals, the building blocks of planets. Through a process called accretion, these planetesimals collided and stuck together, gradually growing into the planets we know today. Closer to the sun, rocky planets like Earth formed. Farther out, gas giants like Jupiter and Saturn accreted vast amounts of gas. Section 7. Earth, a blue oasis in the vastness of space. Earth, in its infancy, was a hot and volatile world. Volcanoes erupted, spewing molten rock and gases into the atmosphere. Over millions of years, Earth cooled down. Water vapor in the atmosphere condensed, forming oceans. The first continents began to emerge from the global ocean. Earth's unique position in the solar system, in what we call the habitable zone, where temperatures are just right for liquid water to exist, played a crucial role in its destiny. Section 8. The Miracle of Life, a Cosmic Confluence. The early Earth was a harsh and unforgiving place, yet somehow, life emerged. The exact details of how life arose from non-living matter remain one of science's greatest mysteries. We know that life on Earth is based on carbon and requires water as a solvent. The early oceans provided the perfect environment for the first simple life forms to evolve and diversify. Over billions of years, life on Earth evolved from single-celled organisms to complex plants and animals, eventually leading to the emergence of humans. Section 9. Our Place in the Universe, a Journey of Discovery. Understanding the formation of the universe and our place within it is a journey of discovery. It reminds us that we are part of something vast and ancient, connected to the cosmos in profound ways. The atoms in our bodies were forged in the hearts of stars, the water we drink originated in the depths of space, and the molecules that make up our DNA were present at the universe's birth. As we continue to explore the cosmos, we gain a deeper appreciation for the interconnectedness of all things and the preciousness of our own planet.